I'm Diego. I also added Mark Burgess to the title slide because he contributed some code that I will show you during the talk of some experimental container integration features we're toying with in CFEngine. So basically, I'm going to try and keep this talk as configuration management tool agnostic as possible, but you know which side I'm leaning to, and I'm a bit miffed by CFEngine not having been mentioned by anyone other than Chris in the opening statement, so you've earned it. Anyway, this is my grossly oversimplified history of computing for the purpose of this talk. So, and the aspect in which I'm focusing is how many things are running on how many things on top of how many pieces of hardware, basically. So we have from few things running on big machines, on few big machines, to many things running on a few big machines with modern mainframes on larger machines, to many things running on many physical machines in the age of clusters and big installations like this. Then we have many things running on many VMs, running on many pieces of hardware, which is traditional virtualization. Then cloud, which is many things running on God knows how many things running on top of how many pieces of hardware, to containers, which is very few things running on very lightweight constructs, running on many of them running on pieces of hardware as we know them. So basically, the needs of what needs to be configured where have shifted one way or the other over the years in the development of our computing infrastructure. And we've gone back and forth a few times between running only a few things per piece of hardware to now running only a few things per virtualized or containerized piece of hardware, which is sort of a similar but not quite so environment. How many here are familiar with the pets versus cattle analogy? Okay, so basically this is an analogy that I learned from a talk gave by Gavin McCance from CERN, but it turns out it was Randy Bias from Cloud Scaling who made it popular, and apparently it was originally coined by Bill Baker from Microsoft. So basically the idea is that servers in the old-fashioned way are like pets, right? We nurture them, we take care of them. If they get sick, we worry a lot. If they die, it's a tragedy. We spend tons of time and money in keeping them healthy. Whereas cattle, well, sure, we care for them. We don't want them to die. But if one of them dies, it's no big tragedy, right? We shoot them in the head, we get another one, and we move on with our lives. And it's the same with machines, right? In the age of traditional server management, we had to nurture our servers to health. We configured them by hand, carefully, painstakingly, over years. And if something happens to this server, it's a big tragedy because it's very hard to replicate, right? How am I going to get all of the time and investment that I put into it? Whereas in the age of virtualization and containers and cloud computing, we are encouraged to treat them more like cattle. We have reproducible servers, we have disposable machinery. So if one of them goes bad, we just kill it, spin up another one, and we move on with our lives. So in terms of how we configure these two types of infrastructure, traditionally configuration management it was born and has leaned more towards the pet side of the spectrum, right? Of course, we automate the configuration, but it's something we build by hand, we build over time, and we apply it to a particular machine. Now, from the cloud computing and container side of things, we're also using configuration management, but more to initially create the images or to create the custom configurations we're using. But once they're running, we don't care so much for them, which brings me to configuration management in the age of containers. The approach we've seen so far is that we use our configuration management tool to do management from the outside, right? So we use it to do image management, to create and maintain my base images, to create, connect, and manage my containers, to structure my applications, to manage how many groups of web server containers I have and DB servers and so on and so forth. But this is sort of a limited view, right? We're only managing them from the outside, and we're assuming each one of these little pieces is static. It's immutable infrastructure, right? And I sort of disagree with that view. And I think the future of configuration management in the age of containers is to still do configuration management inside each one of those little pieces. And the reason why I think this has to be that way is that we've been led to believe that pet or cattle is a binary thing, right? You either pre-configure your systems and you make them completely disposable, or you nurture them and you create custom configuration management policies for them, or configure them by hand and make them into a living, breathing thing that you care about. But I don't think it has to be one way or the other. I think we can have some pieces that are pre-configured in the sense that cattle are, and some pieces that can be tailored during the lifetime of the system in the sense that pets are. So the trick here is to find the correct balancing point in this range, in this scale, right? So how do we do that? So let me show you a bit of examples from some CFEngine demos that we built for Docker integration. So here we have a data definition. It's a JSON file that defines Docker images. And basically, we have CFEngine policy that converts this definition into Docker files and then automatically generates the corresponding images. And you can see here that we're following the Docker layered approach of building images. So I have a CF Ubuntu image, and I wish I could show my mouse here somewhere. Oh, here it is. So I'm building on top of the stock Ubuntu image, but I'm installing CFEngine and SSH, so I can sort of look at what's happening inside my machine. Then on top of this one, I'm building a DB server image in which I'm pre-installing MySQL, the MySQL components that I need, and I'm exposing the MySQL port. Then I'm creating a web server image, which installs Apache and PHP. Then I'm creating, on top of the web server image, I'm creating a WordPress image that installs WordPress by downloading and untarring the WordPress code. And also on top of my CF Ubuntu image, I'm creating a load balancing image in which I install HA proxy. So this automatically takes care of creating my Docker images. And if I change any of these definitions, the next time my CFEngine policy runs, it'll pick up the changes and regenerate all the images that were produced from it, which is actually kind of cool. So this is how I'm creating the cattle side of things, right? These are my pre-configured images that I'm going to just spin up, use, and destroy as many times as I want. Now, the way I do that is through another piece of data definition in which I define the containers that I want. This is also JSON. So here I'm using my CFDB server image to create a DB server container. I'm creating 5 instances of my web server images, which I'm linking to my, I'm linking to my DB server so that they can talk to the database server for their databases. And I'm creating a load balancing machine that is linked to the web servers. And all the links are created automatically. So this is fine, right? I create my images, I manage them. If I need to increase my number of web servers, I just change the number there. If I need to decrease it, I just change the number there. And they come up and go as I want. So far, we're still in the realm of disposable computing. We're still cattle, right? But now, what about the other side? What about fine-tuning that I want to do while the machines are running? How about runtime configuration? And for this, we are running CFEngine in each one of those containers. And this is a bit of CFEngine policy code, which hopefully will not be too obscure, even for those of you who has used CFEngine. Okay, who has heard of CFEngine? There we go. So basically, it's a set of rules, or as we call them, promises, for what the state of the system needs to be. On all of the systems, this is what this condition means, any, I'm doing some Docker discovery, and this basically is collecting some information about the system and determining if it's a Docker container or not for the purposes of inventory management. This information gets uploaded to the CFEngine server, and then I can get nice, pretty reports of what types of infrastructure I have running, which is kind of neat. I'm configuring SSH with the SSH keys that I want so that I can log into the machines. Then on the policy hub, which is the CFEngine server, it's also acting as a Docker host. So this is where I'm creating my containers. This is the machine that reads those JSON files that I showed you, creates the images, and then spins up the containers as needed. Each one of those containers is tagged according to its role. And this role is determined from their host name, actually. It's a very nice dynamic way of determining the role of a host. So containers that have the name web server are tagged as web server, and similarly the others. So on web servers, I'm going to run a set of promises for configuring WordPress. So this is the one that is going to pick up the linking information from Docker and put it in the WordPress configuration and change a few other things. The DB server, this is the one that is going to make sure MySQL is running and properly configured and the ports are exposed and all of these things. And the load balancer, this is actually very neat because it picks up the information about which web servers it's linked to in Docker and automatically generates the HA proxy configuration file so that if you change the number of web servers, then the load balancer adjusts itself and reconfigures itself automatically. So this is the pet side of the configuration, because even while the containers are running, I can still make changes to them. I do not need to create custom images, pre-made images for every single variation of my systems. I can have things adjust themselves on the fly. I can have tiny variations. I can have even within those CFEngine policy bundles, I could have dynamic adjustments based on load, based on, I don't know, time of day, number of processes that are running, anything I could think of. So here I'm combining the two approaches. So I'm pre-building as much as I can, or as much as I think is appropriate, and I'm also delegating some of the final tuning to the runtime of the container. Now, the point that I want to make is that you can go as much as you want to either side of the scale. You can make it so that this is non-existent, everything is pre-configured here. Or you can, on the other side, I could make all of my containers based on the base image, on the stock Ubuntu image for all I care, and just have CFEngine, or maybe this one, where I have CFEngine installed already, and then have CFEngine on this side install MySQL or Apache and WordPress and HA proxy and all the other components that I have here. So I can choose depending on the needs of my infrastructure. Now, there are, of course, trade-offs, and I'm going to continue using the kitten and the cattle pictures. Now, these ranges are completely made up. There's no scientific basis whatsoever, just what I thought was cool. In terms of image sizes, if every container stacks with a stock image and then it's completely configured by my configuration management engine once the container is running, then my image sizes are very small, right? I start with a stock image every time. I don't have anything pre-installed. Whereas if I pre-create images for every single type of machine I want, then I have larger image sizes, of course. But then the trade-off comes in runtime size and startup time. Particularly in startup time, if everything is pre-configured, my containers start immediately, which is kind of the way the Docker community seems to be advocating to do things, which is okay for many purposes. Whereas if I have to configure a lot of things every time the container starts, well, of course, it'll take a bit longer. But it all depends on how much flexibility I want, because there's another trade-off, which is the image proliferation or Docker file proliferation. Docker actually helps a lot because of the use of layered images and the cache, so that not everything has to be rebuilt every time. But there seems to be a bit of dependency hell in Docker image building, right? Because you need, if you rebuild one of the lower layers, you have to rebuild everything on top of it. And the tooling is very good. It manages it nicely, but it's still a concern. So at the end of the scale, if you want to pre-build every image for every type of server that you want to use, well, you'll end up with a ton of different images. Whereas if you configure everything at runtime, you'll end up with just a few. Runtime changes are very easy to make. If you have a configuration management engine running inside each container, you can still do it if you have pre-made images, depending on what's in the image. Maybe you have some scripts, you have some cron jobs, or you have something else that is running and checking and configuring things. But in general, it's harder to do. In terms of the term that is very much in fashion these days, immutable infrastructure, well, of course, configuration management in the container goes completely against immutable infrastructure, right? The whole point of it is to make changes during runtime of the infrastructure. But like Eric said this morning, nothing is immutable, really. I mean, even if you think you have pre-made immutable images, they are still going to change, and you're still going to have to deal with the changes that happens in the infrastructure at some point. And the other thing, this is one that I just added during one of the earlier talks, repeatability across infrastructures, which is something that is becoming more and more important, right? That if I have my development environment in Docker containers, it would be nice to be able to move it over to EC2 for my Q&A, and then over to ESX for my actual production deployments. Now, if I have pre-built images for everything, well, I have to pre-build the images for all the different clouds or types of infrastructure in which I want to run. This is becoming easier with tools like Packer, because from a single definition, you can generate images for all of these platforms. But it's not perfect yet. It's easier if you're running configuration management, because you start with a stock image everywhere, and you run the same configuration management policies on all the machines. I don't care if it's running in Docker or EC2 or VMware. It'll make the same changes, and it'll bring your infrastructure to the same state. Which brings me to a final point that I want to make, and I think I'm actually going pretty fast. So we'll have plenty of time for questions, which is orchestration. Basically, I mean, there's lots of talk about orchestration. Ultimately, I think orchestration can be summed up as, can we agree on what needs to be done and have everyone do the pieces that correspond to them? That's basically it, right? Whether you're provisioning infrastructure or configuring it or sending messages back and forth, it's all about agreeing on what needs to be done and have each one of the participants do it in the time and the sequence and the way in which they're supposed to do it. So how do we do this in CFEngine? And this is, Mark Burgess has been working on some experimental CFEngine syntax simplifications that might make it into the next release. Actually, we just released CFEngine 3.6 yesterday, so go try it out. So basically, what we're saying here, we have a single CFEngine policy that tells the different parts of the infrastructure what to do. Now, Mark likes to use flourish names for methods and things like this, but all of these human readable names are automatically converted to actual bundle names according to a naming convention. So I'm not showing you the details, but you can see that the parent host, so the coordinator, performs a number of setup steps. It does whatever needs to be done. It sets some files. Actually, what this demo does is it distributes files across among the servers. So it creates some files for each child. It sets up a directory where they can drop the files and does some other setup things. Each one of the children, the containers, run some tasks that actually feed the parent with the information it needs. And this services promise here makes sure the actual containers are running. And the way it does that is by integration of Docker with the existing guest environment's promise type in CFEngine. At the moment, this promise type allows you to manage KVM and EC2 and a few other types of virtualized infrastructure. We are working on Docker integration. So we just say, I want a container of this type with this image name down here, and then everything is created, and the machine starts running. CFEngine runs on it, and then it starts evaluating the same policy that I have here, and every one of the pieces does what it's supposed to do. So it's a very simple way of, in a single place, having the definition of what needs to be done. Now, this is not, the general concepts of what I've been describing is not exclusive to CFEngine, of course. You could do the same kind of things with Puppet, with Chef, maybe with Ansible or Salt. It's easier if you have an agent running on each system because it gives it more independence, but I guess you could do it. But there are certain constraints that that we may want to apply for what is running in our containers. After all, containers are supposed to be lightweight, they're supposed to be fast, they're supposed to be beautiful and easy. So we want something that doesn't add too much overhead to the running container. So at the risk of sounding prejudiced, I don't think you want to install an entire Ruby stack and tons of modules on each container. It has to be distributed because containers may come and go. Containers may lose connectivity for some reason. They could be all over the place. If you decide to move this to a non-container-based infrastructure like EC2 or VMware or whatever else, well, maybe they will be disconnected at some point. So it needs to be also resilient to failure. It needs to be independent of a central server and of environmental things that could affect its operation. So I so happen to know a configuration management tool that has these features. But hopefully what I'm saying is that, and the salient point that I want to tell you today is that we should get out of this immutable infrastructure point of view. I don't think it's entirely the way to go. It has its advantages. I think we need to find the right balance. I don't think you need to go entirely one way or the other, but for your own infrastructure, for your own needs, for the type of things that you want to do with your infrastructure, you need to find the right balance so that the infrastructure operates efficiently, that it's resistant to failure, that you can upgrade it when needed without having to rebuild everything from scratch. And well, it's something that you have to decide depending on your needs. And you can do it with any tool that you want. We have fantastic tools for infrastructure management as of late. The Docker and the surrounding environment is a very exciting development. But ultimately, if you're using VMware or you're using EC2 or you're using VirtualBox or whatever you want, the same basic principles apply. So I just want to encourage you to not get boxed into a single frame of thinking about the ways in which you can manage your infrastructure. That's it from my talk. I'd like to make just one little bit of advertising. One of my colleagues asked me that he's looking for people to participate in a user study for CFEngine. Basically, he wants sysadmins who are not familiar with CFEngine and just to test how easy to get started CFEngine is these days. So if you're interested, see me after or send me email and I can tell you more about it. Any questions?
So one of the really cool things about immutable infrastructure, I have to put air quotes around it after today, is the idea that I, as a developer, can run the same thing on my system as the production sysadmin is running production, and at every step along the way because it's an unchanging artifact.
Mm-hmm.
And as soon as you start tampering with that by doing configuration management inside the container, that starts to break down. What's your answer to that?
Right. So what I think is that what you ultimately care about is that the end state of the infrastructure that you use as a developer is the same state as the infrastructure that is running in production or in Q&A. Right? So it's the end state that is immutable or that needs to be immutable, not the initial artifact. Right? So how do you get to that immutable end state? It can be through an immutable artifact that is already at that end state and just runs unmodified. Or it can be through a generic stock artifact that gets then pushed up to that desired end state at runtime. Right? So there are two different ways of getting to the same desired state, which is why I say you have to make the decision of which way you want to go and consider the trade-offs in terms of performance, space, complexity of management, and things like this. Ultimately, you should be, no matter which way you take, you should be at the same end state.
Okay. So follow up to that, I'm thinking back to Joe's presentation earlier where he showed sort of what he called the ideal infrastructure where you had, the 4 tiers of dev, test,
Yep.
staging, prod, and so on. When you sort of keep that layout in mind and what you've just said about, the goal is the same end state, now suddenly we're dealing with, different branches of our configuration management system, and we've got a lot more moving parts, is basically what I'm saying. So now we've got, instead of just passing around the same artifact, the same immutable artifact, we're passing around an immutable artifact, or a mutable artifact, and a set of configurations that we actually know is going to change between tiers. Does that pose us?
And you'll notice that I'm not advocating going fully one way or the other, right? So I think you have to find the balancing point. You'll see that in my demo, I was already pre-installing the software that I needed, and I was just doing final configuration at runtime, which is, I guess, for this particular case, is an appropriate balancing point. You're right. You have many more moving pieces. So you're shifting the complexity in one sense from one part of the chain to another part of the chain, right? But you still have it. So it just, where is it easier for you to manage that complexity, right? So depending on the needs that you have, then you need to decide where this is. And for many, one reason why this idea of immutable infrastructure has become very popular is because a lot of people feel that it's easier to manage complexity when you build the images and then just have developers or users use those images and not have to worry about how things work. But ultimately, there are still moving pieces inside those runtime images or those runtime VMs. So you still need to worry about managing those pieces, even if it's just making sure the daemon is running and the correct port is configured and whatnot. There are still some sliver of moving pieces. So you still need something to manage that. And if you put something in place to manage that little bit, then you might as well consider the possibility that in some cases it'll be advantageous to expand its reach to do more of that configuration at runtime rather than build time.
Cool. Thank you.
Questions?
Another comment. I love the cattle trade-off and this idea of how far you go one way or the other. Something we've been struggling with, moving from very homegrown tooling to more standardized tooling, and this idea of having a pre-configured appliance that we just fire up, is when it comes around to maintenance and small security fixes, or you want to add one node to a cluster, and that means updating an app config on all the servers so they all know about each other. Those kind of actions that are very small, but I would hate to throw away a 5-node cluster to make the new 8-node cluster and the hour and a half that it takes to provision that,
Exactly.
when if I could just push out a config and hup the server, not even touch the server, and it just picks it up. Those kind of small pet changes are very nice to have agents or the ability to SSH into a box and
Absolutely.
and push those configs
Yeah.
out. So I guess maintenance in general is one of these huge things to know, or a way to rebuild images. So I guess something I'd like you to comment on out of that schema, runtime changes or maintenance applications, whichever way you care to go, and you could argue both sides, the cat and the cattle, would be when I come around to annual maintenance of a whole host of machines, how do you update all of your, say, Docker images, or what are these images you're building dynamically? We build our stacks and our configs dynamically, so that it's very similar to previous years, and keep rolling changes forward. So there's a required maintenance of all of the pieces in this infrastructure. And
Right.
yeah, some comments in that space I'd appreciate from
Yeah,
maintenance.
I think one way in which this can be managed is moving to the orchestration part of the talk. I mean, once you have an infrastructure that allows you to tell each machine what it needs to do, and so you have control both from the inside of your running infrastructure and from the outside of the VMs or the containers or whatever you're doing. So you can, for example, when the time for the maintenance window comes, you can, in a rolling fashion, bring down some parts of your infrastructure, update the images, or update the images, and then in a rolling fashion, bring down your infrastructure and bring them up with the new images. And do this in Windows so that you don't lose your entire functionality all at once. So the sort of thing that you would do by hand in bare metal infrastructure, but you have much more flexibility to automate it with the tools that we have today, and the abilities of managing machines and starting them up and down as if they were regular processes. In terms of what you said about the ability to just update your machines instead of having to bring down the entire cluster and bring it back up, one of the things that we used to say when we were starting with CFEngine, CFEngine the company a few years ago, is that we were trying to move away from the age of golden images. And probably many of you remember this. I worked at both IBM and HP, and we used to have these CDs with the golden images for the laptops. So that was the image, right? That was the corporate image, and that had all the applications they were allowed to use and all the configurations for the mail servers and the print servers and everything that was done. And if anything had to be changed in those golden images, it's a huge effort, right? You have to rebuild the image and then burn it onto 300,000 CDs and distribute them to all your employees. It's a huge expense, timely, very time-consuming, costly, and error-prone to no end, right? So one of the terms in CFEngine that I have used is that the ability to do surgical changes, right? Just go in and change just what you want. Just change this line in the configuration, just start one process, stop another, and do these kind of changes without having to rebuild your gold image. Now, with immutable infrastructure, we're sort of going backwards to the gold images, right? We're, again, of course, now it's far orders of magnitude easier to manage because everything is virtual and we don't have to ship physical things anywhere. But you still have this concern of managing the images, which I still feel it's a bit of a step backwards from where we want to go. Did that sort of address your concern? Okay. I rambled in response, so it was okay. Any other comments, questions? Oh, well, thank you very much.